All right, this is our FSA Need to Know packet. If you don't have one already, make sure you pick one up before you continue watching this video. You will be using this packet until the FSA, so don't lose it. You can use it for help with your homework. You can also use it for help on tests, so make sure you're taking good notes. And of course, if you're absent, there's always a video, so look for the video you're missing and watch that one. Today we're working on the standards NS1 and NS2 that talks about number sense. All right, and of course, make sure you're listening to the video. Page 4, which is the first page in your packet, talks about NS1. And of course, there's going to be no calculators for this lesson, for the next few lessons anyway. All right, the following numbers are irrational. Well, is this one irrational? If we remember, irrational numbers are ones that can't be written as a fraction. Let's write that down here. Irrational numbers can't be written as a fraction. Okay. So can we write this first one as a fraction? Sure we can. We could put the -5 out front and the 22 over 100. So is this an irrational number? No, because it can be made into a fraction. Pi, you should know, can never be made into a fraction, so it is correct, this is irrational. All right, same thing with the square root of 3. Since it's not a perfect square, it cannot be written as a fraction, so that is true, it is irrational. Well, just by definition, obviously this one is rational, which means it's not irrational. And the negative square root of 16 is fine. The negative stays on the outside, and we know the square root of 16 is 4. So -4 can be written as a fraction, just put it over 1. So this is also false. So the only two irrational numbers are pi and the square root of 3. The rest are rational. All right, which number cannot be expressed as a decimal? And what I mean by that is a decimal that stops, that's what terminating means, or repeats, and you know what that means. It goes on and on forever. Well, that's talking about something like 1/3. Well, 1/3 is just 0.3333, and so on. Well, that one can be written as a decimal. That's the decimal, in fact. And we have -3 for C here. -3 would just be -3.0, meaning it stops there, right? If there is no other decimal, so that one's fine. And 0 divided by 3, as long as 0's in the numerator, it's okay. 0 divided by anything is just 0, and you could do 0.0. That could be written as a decimal as well. The only one that can't be written as a decimal that either stops or repeats is answer choice B, because it never stops and never repeats. All right, to convert 23/99 into a decimal, we are going to divide. Divide 23 by 99. That means the top dog goes in the house, and this 99 comes outside. Put a decimal here, line it up on the top as well, and we're going to see what we can do. All right, can 99 go into 23? No, so we put a 0 here. All right, since that doesn't work, we can add a 0. Does 99 go into 230? Yes, it does. It can go in twice. And of course, there's no calculators here, so make sure if you need to, do your work on the side. 2 times 99 will give me 198. All right, and when I subtract, let's see, I'll get a 2 here, because that becomes a 10. This became a 2. I'll need to borrow, and 12 minus 9 is 3. All right, Then we bring down another 0. Does 99 go into 320? It sure does. About 3 times. And 3 times 99 gives me 297. All right, I'll need to subtract. Let's see, this will become a 10. And borrow here to make that an 11. 10 minus 7 is 3. 11 minus 9 is 2. And of course, oops, this is a 2, I'm sorry. 2 minus 2 is nothing. And then so we bring down another 0. Maybe you're noticing something here. 99 into 23 again, or 230 again, is what we started with. It does go in again twice, which gives me the same thing I started with there, the 198, which when I subtract will give me again 32. And it's going to go on like this, right? Another 320, we just did that. 320 goes in 3 times, and it's going to repeat like that. Okay, so our answer here, we'll put it to the side, is 0.23 with a repeater bar over that. And hey, maybe you noticed something. Remember, when something repeats, to change it into a fraction, you just put it over 1 less than what you would have put it over if it was not repeating. Okay, 23 over 99 is 23 repeating. All right, so as you can see here, we're going to do that same thing. So if you didn't know what I was talking about, I'm going to do it here for you, number 4. Well, let's talk about first, I'm going to draw this a line here, so draw that line with me. Let's talk about if we had 0.5, if it didn't repeat, it just stopped. Well, that's just 5 over 10, and of course we could reduce it, right? We put the 5 over the 10 because it's in the tenths place. Well, now this number is really 0.5 repeating, right? It's just that one number repeating. Well, like I was saying in the last one, instead of putting the 5 over the 10, we're going to put it over 1 less. 1 less than 10 is 9. And simplify if you can, but we can't here, so that is the answer. That's our little trick. All right, now we're on page 5. The square root of 51 is closest to which whole number? Well, if you don't know off the top of your head, what you can do is make yourself a number line with all the perfect squares on it. For instance, if I put the numbers 1, 2, 3, and just go up to whatever you need. I'm going to go up to 8 in this case. 4, 5, 6, 7, 8. And I know I need to get to 8. You might not know what you need to get to, so you just do it until you're done, until you figure it out. Well, I know that 1 times 1, if I'm here, 1 times 1 is 1. So that means the square root of 1 is this 1. All right? Don't circle that 1, though. I was just showing you what I was looking at. So the square root of 1 is 1. Well, let's do this 2. 2 times 2 is 4. Therefore, the square root of 4 is 2. And we can go on like this. 3 times 3 is 9, so the square root of 9 is 3. 4 times 4 is 16, so the square root of 16 is 4. And then we have 25. I'm squeezing it in here. We have 36. 7 times 7 is 49. And 8 times 8 is 64. All right? So if you look in between those square root numbers, I want to find where the square root of 51 would fall. Well, it looks like it would be in between these two, right? 51 comes between 49 and 64. Therefore, it's going to be between 7 and 8 because it asks which whole number is it closest to. Well, let's compare for a second. 51, compare that to our 49 and our 64. Which one is it closer to? How far away is 49 to 51? That's a difference of 2, right? And 51 to 64, well, we could subtract 64 minus 51, and that would give us 13. So it's closer to this 49 which therefore is, our answer will be this right here. The square root of 49, which is 7. So make sure you know that's your answer. Extra circle it if you need to. Put a star next to it. Your answer is 7. What is the best estimate for the square root of 40? Well, again, on your number line, I'm not going to make every number now. Okay, you can see that it's going to be somewhere between the square root of 36. I know that one, looking at the number line next to you, and the square root of 49. And of course, the square root of 36 is 6. The square root of 49 is 7. I know it's in between those two. So the only ones in between 6 and 7 would be B and C, because it's not exactly 6, we know that, and we know it's not exactly 7. So the question is it closer to 6 or closer to 7? That will help me determine if it's B or C. Well, 40, let's see. Let's do this like this. 36 is here, 40 is here, 49 is here. How far away are these? That's a distance of 4, and these are a distance of 9. So it's closer to this 36. So which one is closer to 6? That would be answer B. All right, which irrational number is between 2.6 and 2.7? Well, since they gave you a number line, let's just look for 2.6 and 2.7. Well, here it is, 2.6 and 2.7. As long as you know what irrational means, because it's a vocabulary word you should know, well, here's one right there. The square root of 7. I'm going to point that for down here. Our answer is the square root of 7. Okay? That's the only thing between 2.6 and 2.7. All right, which is larger, 2.4 or the square root of 6? And if you have a different color, that might help you with your notes here. I'm going to do this one in red. So 2.4 is right here. I'm going to circle it. And up here is the square root of 6. So 2.4 is here, square root of 6 is here. Which one's larger? Well, obviously, as we go to the right, things get larger. So the answer is the square root of 6 is larger.